앱이 없어. 앱이 없어. 나보다 더 늦었어. 없어. Hello.
Hey, Peter. Can you hear me all right?
Yes. I can hear
Good.
you.
Okay. Good. How are you doing today?
Good.
Good. Good week at school so far?
Yes.
That's good. Yeah, I don't know. This is my second week of school. I'm not excited to be back. I miss being at home.
Same. Everyone does.
Yeah, vacation's too nice.
Yeah.
Okay. So I guess we can get started. What are we working on today? Math?
Well, I'm done with I'm pretty much capped at math right now. Like I feel like I'm pretty good at math right now. Like, do you know what I mean?
Uh-huh. Yeah, like you want to
Yeah.
focus on another subject or something?
Like maybe we can do math, but like what is it? Like a more advanced? Like right now we've gotten into like 5 squared 6. I feel like that's how you say it. Times, 7 squared, like that stuff.
Oh, I think I know what you mean.
Can I write it for you?
Oh, yeah, sure. Here, let me give you annotation permission. I don't think you have it yet.
Okay.
Okay, you should be able to annotate now.
Okay. Like 5 squared 5. Like that.
Oh, okay. Like doing the math out?
Yeah.
Okay. Yeah, I think I can show you something that you might find interesting that's kind of related to this. And if you've already seen it, let me know, okay?
Okay.
So what you did is basically we have some big number, a base, and then some little number, an exponent, which you know from school, right?
Yes.
Okay. But we have what are called properties of exponents. Okay?
Uh-huh.
So one of the properties of exponents has to do with multiplication.
Mhm.
So for example, if we have the exponents, let's say 3 squared times 3 to the 5th,
Mhm.
what we can do is we keep our base the same, since our base is the same for each number. And so we write it as 3, and then we actually add our exponent. So 3 to the 2 plus 5. So this is 3 to the 7. And if we think about it, this makes sense, right? Because this is 3 times 3, and then times 3 times 3 times 3 times 3 times 3.
Oh.
And so this is one way that we can like rewrite exponents to make them a little bit more organized.
But we can also just do it like separately, right?
We can do it separately. The reason why they want you to learn this in school at some point is because eventually what happens is your base is not a number. It's a letter or a variable instead. And so then it becomes really helpful to be able to rewrite this as x to the 7th, right? Because we can't solve that anyways. We just have to write it down at the end. And so that's why they have do you need water or anything? Are you okay?
My throat just hurts. I've been jumping on the trampoline all day, so like, yeah. Just learned how to do a backflip and got my whole back broken with those.
Oh no.
Yeah.
Okay. And then oh no. Oh, what did I do? Oh, okay, it's back. It's back. Okay. I need an eraser. I accidentally started writing the wrong word here. Okay. And then the other thing that we have is we'll call this exponents on exponents. This is kind of interesting. So let's say we have 3 squared in parentheses, and then we're taking that entire thing to the 4th power. Okay? And so 3 squared to the 4th power, what we do is instead of adding the exponents, we multiply them. So this is 3 to the 2 times 4 power, which is 3 times 8. And so these are some properties of exponents that eventually you'll do with variables instead of numbers to make problems easier to solve. So what I'll do is I'll write down an example of each of these and you tell me how you would simplify it, okay?
Okay.
Oh, I gave you a trick question. I'm not going to do that yet. That's a little mean.
Hey, my first question, and you're tricking me.
I erased it. I wrote a non-trick question. I decided to be
Okay.
nice.
I don't know. That's pretty sus. Oh
It,
God! Did you hear that?
it sounded like something fell.
Something big. And as you can see, I'm using this mic, so just hearing it from that side, imagine how loud it is on this side.
Yeah, that's gotta be crazy. Okay, so what would you write for question 1 and question 2? And you can look at the notes above.
Oh God, I'm gonna turn off this light. It's hurting me. Okay.
Sure.
um. Annotate. And 412.
Okay, remember, we don't multiply the 2's. We keep our base the same. So it's 2 to the 12th.
2 to the oh.
Mm-hmm. Here, do you want to erase and rewrite as 2 to the 12th?
Okay.
Okay, looks good. And then what would you do for number 2? So this is 2 to the 7th in parentheses raised to the 2nd power. Okay. Does that say 28?
Yeah.
Okay, not quite. And the reason why is we don't multiply everything together. You did 2 times 7 times 2, right?
Uh-huh.
Guessing. Okay, so what we do instead is we keep our big 2 the base the same, and
Uh-huh.
then we look only at the exponents and we multiply those together. So what's 7 times 2?
14.
Uh-huh. So this is 2 to the 14th power.
But question.
Uh-huh.
For number 1, why don't we multiply the base the
Okay.
number?
That's a good question. The reason why is because
Cuz sorry, cuz then it won't it be an unsolved question?
so yeah, yes and no. So we could solve this out. We could do 2 to the 12th power. I think it's a pretty big number. Here, I would have to do that on my calculator. I don't know that one off the top of my head. So let's see. So 2 to the 12 is 4,096. So it's really big. Okay, so we could solve it. But the reason why we don't want to solve it is because usually when you do math later on, these aren't numbers. These are letters, right? And so for letters we can't actually solve.
Yeah, my dad tried to get me to do one of these like more complex of these in 2nd grade, and I tried it. Yeah, I managed to get it down, and then the next day I forgot all about it.
Yeah, that's okay. Yeah, so basically the reason why we don't solve all the way is because I'm not giving you like a real problem. I'm just giving you numbers instead of letters right now, so it makes a little bit more sense.
Okay.
Yeah. But usually there's nothing to solve, right? Because if I told you, okay, find x to the 3rd power, you'd just be completely confused. You'd be like, well, what is x? I don't know. So,
Yeah. Well, x isn't x technically is a unknown. I mean,
mhm.
yeah, x is an unknown. unless
Yeah.
they have, unless it says like a equals x plus 17 or something, and then
Mm.
they show you what x is.
Yeah, they gotta tell you what it is. Yeah, so that's why we don't solve all the way, and it's just because usually these would be the base would be a variable like x, or you could use another letter like y or z if you wanted.
A B C D E F G H I J K.
Mhm. Yeah, the most popular ones are x, y, and z because that's our coordinate plane. Like you've seen this on the graph. We have our x, our y, and then if you get really fancy, you can do a third dimension z. And then the other variables that they use a lot are a, b, c, and that comes from a triangle.
Triangles, the fundamentals of life.
Okay, so what I'm going to do now is I'm going to give you the same type of problems, but I'm going to give you variables instead of numbers. Does that sound okay? Just to get some
Yes.
variables? Okay. Okay, the second one might be a little challenging, but just do it the way that we did it earlier. Don't let that negative sign distract you.
Hmm.
Okay, good. You added 5 and 3 to get 8. Perfect. Kept the base the same.
I need to thank my dad for every single bit of torture. At least I got some kind of remembrance. 5? Hmm.
Okay,
5?
so
You're probably
how did you get 5? Did you do 10
yeah.
divided by 2?
10 times 2.
Okay, what's 10 times 2? I
Oh,
think
wait,
you
no,
made a
sorry,
math
sorry.
mistake.
Sorry. 8 there.
Okay, 10 times 2. 10
10 times
multiplied by 2.
10 times negative 2 equals 5.
20, right?
Wait,
10
this
times
isn't this a negative sign?
Yeah. You've learned negatives in school, right?
Yeah, but if we add 10 and 5 or we multiply it, then it'll be negative 5. I mean, it'll be 5. 10 times negative 2 equals 5. We cross this out, switch this into division, and make
Okay.
this positive.
Okay, you do that for addition and subtraction only. Yeah, addition and subtraction only. For well, that's good. It's good that we got to review positives and negatives too. So what we
Benefit
do,
of the doubt.
yeah. So what we do for
Uh-huh.
multiplication
Uh-huh.
is we just multiply like normal. So what's 10 times 2?
10 times 2 equals 20.
Okay. And then a positive times a negative is always going to be negative. So we make it a negative 20. So a positive times positive is going to be a positive. A negative times a negative is going to be a positive. But if we have one of each, then it's going to be negative.
Okay.
Does that make sense?
Yes.
So we multiply like normal. And this is the same for the division too. So we multiply, divide like normal, and then we look at the sign.
Okay.
Yeah.
Okay.
Here, I'm going to give you another one just to make you happy. So what if I had 10 minus negative 2? What would this be? This you can do your leave change opposite because it's addition, subtraction.
10 minus negative 2 equals 12.
Perfect. Good job.
Yay.
Yeah, so just remember that addition, subtraction is leave change opposite. Multiply and divide, do it like normal, and then you just look at the sign at the end.
Okay.
Okay, so let's go back to our question 2. So what is z to the 10th power in parentheses to the negative second power?
This hurts, you know.
Why does is if it's too hard, we can do something else. Let me know.
Set Z negative 20.
Exactly. Perfect. Yay,
I wonder
got it.
what that would be.
Yeah, I mean it depends on what Z is, right?
Hmm.
Okay. So I'm going to save the screen. We'll do some more examples of these, and then I want to show you something that has to do with negative exponents that I think you might find a little interesting. Hopefully, either that or you'll hate me. It'll be one or the other.
Probably hate you.
Probably.
Yeah.
That's okay. Most of my students feel like that at some point.
At some point.
Yep. Okay. Let's do a to the negative 2
Okay.
times a to the 5. And then let's do b to the negative 3rd to the negative 4th. So kind of similar to last time, but I'm probably being a little bit more mean with the negatives this time. We'll see.
Hmm. Okay. Sorry for my moaning.
That's okay.
Dot is multi, right?
Yeah, dot means multiply, which means we want to add our exponents together.
Hmm.
A to the 3rd, perfect. Good job. Exactly right.
This is scaring me.
Okay,
Bam.
your B is right. You got half of it done.
I don't know if the B's right. Looks a bit wanky, don't you think?
Well, now it
Okay.
does. Now it looks like an 8.
Okay. A 3 and B 12.
Yes, very good. How did you know that 12 was positive?
Got that IQ in there, yes.
Okay, yeah, negative times a negative is a positive, right? Our IQ tells us that. Okay, so yay, good job.
Mm-hmm.
So just a quick recap. So when we multiply
Mm-hmm.
numbers with the same base, so both of them are a, okay, we add the exponents.
Cool.
And then when we use parentheses, I
Mm-hmm.
can never spell parentheses right, multiply. Okay, so now I'm going to throw something that might be a little bit of a trick question. Okay, what if I had a to the 3rd,
Uh-huh.
b to the 4th?
8 to the 3rd times B to the 4th. Okay. And that is A plus B and oh God, this is exactly what my dad taught me, but now I forgot. Like this?
Okay, not quite, not quite. And so actually, the reason why this is a trick question is because we
Uh-huh.
can't do anything with it. We can't do anything at all.
Oh yeah,
And
you
that's
just put parentheses, right? Oh wait, no, not parentheses. You
you can
just
just leave it. You can just leave
yeah,
it. If
yeah.
you wanted to, you can get rid of the dot if you want. As if when we
Uh-huh.
have two letters touching, we know that they're or two letters, two variables touching, we know that they're being
Uh-huh.
multiplied. But since A and B are different, we can't do anything with it. That's as good as it's gonna get.
Uh-huh.
It looks a little ugly, right? I wish we could
Yeah.
do more with it. Okay, I'm gonna give you
No,
another.
no one wishes.
Okay, I'm gonna give you another kind of a trick
Okay.
question, but now you know my tricks. So,
Uh-huh.
can we simplify this? Can we do anything here?
Uh this is this type of stuff. Oh my God, no.
No, right? Why not?
Because what is it? Yes.
All the bases are
Uh,
different,
okay.
right? We have one X, one Y, one Z. And if I told you to add up, I don't know, just 3 random things. If I told you to add up, I don't know, your desk, a duck, and like the sky, you just look at me like I'm crazy, right? They're completely
Yeah.
different things. You can't put them together. And so this we just keep the same too.
Mhm.
Okay, but that was my trick that I wanted to show you. The other cool thing that we can do with exponents that I thought you might want to know is we've had this before. So we had a to the negative 2, right?
Yes.
What the heck does a to the negative 2 mean? We know that a to the 2 just means a times a, right?
Yeah.
But how do we do it with a negative sign? Well, what that means is that actually we have a 1 on the top as a numerator, and we're doing our a times a on the denominator or the bottom of the fraction.
Mhm.
So if I gave you x to the negative 1, or x to the negative first power, what this is really saying is that this is 1 over x. Or if I could even do a bigger number, x to the negative 100, that would be 1 over x to the 100. Does that make sense? Kind of how the negative side just means that we're on the bottom instead of the top?
Yeah.
Yeah. Another way to think of it sometimes is like
Uh-huh.
whenever we have a number that's not a fraction, it's almost like there's an
Uh-huh.
invisible 1 here in the denominator, right? Because
Uh-huh.
dividing something by 1 doesn't change anything. So it's kind of like we flip these whenever it's negative. Okay, I'm going to give you some examples now of rewriting negatives, okay? So I want you to rewrite, here, I'll switch it up. J to the negative 42nd.
Ah. J to the negative 42nd.
Yeah. And I'll give you an example since we erased the last screen. But like x to the negative 1 is the same as 1 over x.
Mm.
So knowing that, how would you rewrite j to the negative 42nd?
I am confused. Sorry.
Okay. No, that's all right. Here, I think maybe this one was, I threw in too much new stuff at one time. So I'm going to give you an easier example. So let's say
A
we have
new
x
really.
to the
Uh-huh.
negative 3, right?
Uh-huh.
So what this means is we have a fraction. 1 is always going to go on top. And then on the bottom, we put the positive version of our base and exponent. So always 1. And here is our base to our positive exponent. Okay, so here, let's retry. How would you do j to the negative 42 or negative 42nd power? So remember, we always start with our 1 on the top, and then from there we can look at our base and our exponent.
One
Okay?
at top.
Uh-huh.
J42.
That's it. Yep, just j 1 over
Uh,
j to the 42. Okay,
okay. Yeah,
let's
yeah,
do,
I feel like this is way ahead of my grade level now.
yeah, this is algebra 1 or algebra 2?
Algebra.
Yeah.
Algebra.
I see. I can be tricky like that. I started out with the numbers like you're doing in class, and then we worked our way up to something crazy.
I wouldn't say tricky, but I would say deceiving.
Deceiving. Okay. I'm very deceptive. We'll go with that.
Yep.
Okay. Let's do this one. This one will be so easy after I gave you 42. So what's y? How can we rewrite y to the negative 5th power?
Y to the negative fifth power. There?
1 over y to the 5th.
Uh-huh.
Perfect. Good job. Is this kind of making sense what we do with the negatives? How we
No.
rewrite? Okay.
No.
If it's not making sense, all you got to do is remember this pattern.
Okay.
So the top is always 1, or we always leave the top alone, and then we put the base to the exponent on the bottom.
Lord help me.
Yeah. Here, I'll give you an example with real numbers if that'll help. I think
Okay.
it might be helpful. So let's say we have 3 to the third power. This is 3 times 3 times 3, right? What's 3 times 3 times 3?
3 times 3 times 3 is 9, 18. Wait, no, 27.
Mm-hmm. Yep. So 3 to the third is 27. So when we have a positive exponent, does it get big or does it get small? It goes from like 3 to 27. Is it get bigger or smaller?
Bigger.
Okay. Number gets bigger. Okay. So when we have a negative, we want our number to get smaller. And so I'm going to give you an example of that.
Okay.
So let's say we have 3 to the negative 1. That's 1/3. Because we put 1 on the top and then 3 to the first power on the bottom. So this is 1 over
Okay.
3. Okay. Let's say we have 3 over negative 2. Well, now we're just doing 1/3 times 1/3. Or if we wanted to, we could rewrite this as 1 over 3 times 3. Both of these are the same. Okay, so what's 1/3 times 1/3?
1/3 times 1/3 is 1/9.
Uh-huh. Yep,
Okay, I
very
thought I
good.
was wrong for one
And
second.
then, yeah, you got it. Okay, and then what's 3 to the negative third? So 1/3 times 1/3 times 1/3.
1/27th.
Yeah. So kind of the
Uh,
reason why negatives work this way is because when we have a positive, we want to get bigger, right? And so for the
yes.
way to make something smaller is to put it on the bottom. Yeah, and so that's why it is the way that it is. To give you an example of this, let's say that you're splitting something in half.
You're frozen. Like I can hear you, but you're like frozen. Ooh. Okay. Hello?
Can you hear me?
Yes.
Yeah, I think my Zoom got disconnected for a bit.
Oh, what happened?
I don't know. I think I just have bad Wi-Fi maybe in my apartment.
Because that's been happening a lot with everyone I Zoom with now.
Oh, I don't know. Maybe it's your Zoom then.
Hey!
I think also a lot of people are using Zoom right now though,
Yeah.
because college just started up for a lot of people. I don't.
College?
Yeah. Yeah.
Yeah.
So a lot of like elementary, middle school, high school, you have the option to go in person. College is all online. So there are a lot of people using Zoom that weren't using it earlier. And so maybe I don't know, the website just has more people on it. Okay. Yeah, but what I was saying is like let's imagine we're splitting something in half, right? So maybe we
Uh,
have something delicious like a chocolate bar. Okay, so we split it in half. And we
why
split
would
it in
you
half.
split it in half? You
I don't.
monster.
Maybe your mom makes you or something. So we split it in half, and then we split it in half again, and then
Uh-huh.
we split it in half again. And then if we're really evil, we split it in half again.
Ooh.
And so what this is
Uh-huh.
like this is visualizing our negative exponent. So what I
Uh-huh.
actually drew right here is 2 to the negative 4, or 1 over 2 to the 4, which is 1/16. And so whenever we have a negative exponent, just think of like your mom keeps on making you share your chocolate bar and it just gets smaller and smaller and smaller. And so negative exponents always get smaller, and so we stick them on the bottom instead of the top. Is that a very sad example to think of? The chocolate bar just slowly turning to nothing?
It reminds me of my childhood.
I think you're still in your childhood.
My childhood. Childhood.
Uh-huh. Okay. Yeah, but that's the picture I want you to think of for the negative exponent. It's just like this chocolate bar just getting smaller and smaller and smaller. Okay. Any
Okay.
questions for me about this?
No. I
Okay. Is
only
this
have I only have sad tears
only sad tears?
of a past memory lost forgotten.
Of what? Chocolate bars or math?
Chocolate bars.
Oh.
Always
Okay,
chocolate
that's good.
bars.
That that's exactly what I want you to have. I want you to be
Okay.
sad about this chocolate bar getting stolen.
Hey!
That means you understand the math.
That is true.
You get the point. It's okay. The
I'm on
chocolate bar died.
point.
Yeah, the chocolate bar died for a noble cause, and that was you understanding exponents. So rest in peace, chocolate bar.
Okay.
Okay, well, I think that's actually about it for today. Do you have any questions or things you want to talk about before I go?
No.
Okay. How was today on a scale of like one ridiculously easy to 10? This is so hard. You're evil. And somewhere between 1 and 10. So easy to evil. Where were we?
What?
Okay, so if we were to rate
I mean, uh,
how hard class was on a scale of
uh,
1 to 10,
okay.
1 being easy, 10 being evil, where are we?
Evil. Always evil.
We're always at evil? Oh
Uh-huh.
no. Okay. Well,
Well,
I don't
I mean,
know.
it is
Well,
math, so
very true.
no excuse.
Yep. Oh, I was going to tell you a joke before I went. Oh wait. I'm trying to exit out and stop my screen share first. Okay. So, why did the math teacher have to go to the therapist?
Uh, cause she had a math addiction.
She had so many problems. No, no laugh. Okay, that's all right. I'll laugh at my own jokes.